All right, we're going to go ahead and get started. If anybody else jumps in, they can get in here. But apparently there was a mix up with the URL because I posted this URL one through the social media on LinkedIn and as well in the Georgia Oracle user group um, meetup site. So don't know why I pushed everybody else to another meeting, but we'll, we'll have the recording and they can actually go and see the recording as well as it's posted. So I appreciate everybody showing up today. Very much appreciated. This was kind of a last minute presentation that I did at Toronto Oracle User Group last week, and I figured it was probably be pretty good for the wider audience to really see it and to really understand what this is going on because zero ETL is actually is a new concept. It's kind of interesting. I actually stumbled across this a couple of weeks ago doing some research on some other things for Golden Gate, and I thought it was an interesting concept, and I was like dug into it, and it was just kind of like, I think people need to know a little bit more about this. So the title of this presentation is really around Zero ETL, accelerating data insights with Oracle GoldenGate. And what I really want to point out with this is really what Zero ETL is and the difference that it brings to everything, as well as with the what GoldenGate does in terms of pipelines and bringing everybody together and moving data across the board. Oh, my clicker's not working now. Okay. Anyway, so many of you probably already know who I am, so I'm not going to go in depth on this, but Bobby Curtis, I'm the owner of Rio Data, based out of Atlanta. A lot of us with Rio Data are in Atlanta and in Austin, Texas, near everything. But for myself personally, I'm in Atlanta. Former author, haven't written a book in quite a few years, but I am an author along with a few other friends in Atlanta. A regular speaker. I took a break from speaking, probably from 2017 to 2020. I didn't do a whole lot of speaking, and due to the pandemic, did a few webinars, but also got getting back out there on the circuit. Got my Oracle Ace Pro back, working to get my director back at some point. But in the end, when it comes to Golden Gate, I was also the product manager for Golden Gate for 3 years. That's the reason why I didn't really speak during that time a whole lot. If you want to reach me, the usual channels are out here as well. But if you want to ping Rio Data directly, just change DBA solved to Rio Data, and you'll still get everybody in the company, or at least get to our website and be able to navigate from there to get to the people. So, but as we jump into this concept of zero ETL, it's actually kind of interesting to look at the timeline of what we determine as modern data platforms, right? Because this kind of lays the foundation or gives the highlights of why we're getting to this term zero ETL. So the modern data platforms, or what we consider the cloud today, actually started back with the foundations back in 1960. Whereas the concept was really, or the core tendencies was really to provide a service for multiple people sharing a network across the board. If you remember back in the 60s and 70s, you always had the term timeshare on these big mainframes and things like that. That's where it really started. And then in the late 70s through the mid 80s is where what we consider the melting pot of the IT industry really started to kind of sink in. And for the vast majority of us who are probably in our 40s and younger, we were not even around, or we were just coming about to a degree during the melting pot era. So this is where we started really uptick of the internet. Computers started getting connected online through modems, and the example I like to use here is really around AOL, right? Because that was really the first time when people had personal computers in their house, connecting to the internet, going to chat rooms, and doing all these other things. It was really around that time frame. Then you started getting into the 1990s when the term big data was really first coined. And we hear a lot about big data back in like the mid 2010s or early 2010s, maybe late 2000s. But in reality, the term big data was coined back in the 1990s. And then later on, towards the end of the 1990s, you started getting the term cloud being used. It was actually first used by Compaq, that which we all know Compaq was a computer provider or a personal computer provider on the hardware side that actually eventually got bought by, I believe, Hewlett Packard at some point. But in 1996, they were the first ones to coin the term cloud. Now, at that point, cloud was still an ambiguous term. People were just kind of like, what are we really doing here? And you still had the concept, like I said, from the 1960s all the way until that, up to then, around time sharing, right? Because we made that transition from mainframe time sharing to personal computing on your personal desktops at home, trying to understand how this stuff really works, connected to the internet and all these other fun things. And then a year later, in 1997, the term cloud was used again by a professor at Emory University. But what he was describing in terms of the cloud word was really grid computing. And so as we get from the 60s to the 1990s, one of the biggest companies in the IT industry, i.e. Oracle, was actually started in the late 70s when they started building the Oracle database initially, right? So all the way through there. So by the time you get to 1997, this concept of grid computing is where the foundation, in my opinion, is really where cloud really started. Because if you remember in the late or about 2002, you had Oracle had a product called Parallel Server, which was later termed Oracle RAC, which is, we all know, it was 9i. You had 8i and 9i databases that were based for the internet. And then you had 10G and 11G, which 11G a lot of people are still on today. The G was standing for grid, right? So i.e. the grid computing. So Oracle was actually a forerunner of the cloud by enabling its customers to horizontally scale their database environments, and then eventually that went into the middle tier, and then the application tier, and so on and so forth. So by the time you get to the end of 2001, going into 2002, Amazon announced Amazon Web Services, right? And they announced it in 2002. But a couple of first products that they released was really around the Oracle stack. Oracle Grid Computing, Oracle Databases, Oracle MySQL. All those were actually built into the RDS platform, giving them a model which was to be based around demand, allow small businesses to consume these enterprise technologies without consuming the cost. And so that was really the inception phase between 2001 to 2004. That spurred on the growth of Gen 1 Cloud, where, again, in 2002, Amazon had the jump on everybody with the demand model. And so by the time between 2005 to 2010, people were just waking up and starting to realize, hey, what can we do with this cloud model? What can we do to build this stuff out really ingeniously and scale this thing a little bit more, not necessarily horizontally, but vertical? Then you get the Gen 1 clouds. Now, everybody who talks about Oracle Cloud will admit that Gen 1 of Oracle Cloud absolutely sucked, but it was there. But Amazon had the lead. And so, excuse me. And so about 2010, OpenStack came out. OpenStack launched and eventually was bought by Red Hat. So that's why you have Red Hat OpenStack. And then you have 2011. Prior to that, up to 2011, there was no really set architecture on what a cloud should look like. It was just pretty much a bunch of resources you threw out there and said, hey, use this on demand. So other data centers were trying to do the same thing, everything else. And so Microsoft released the first reference architecture, that which eventually became Azure, and that launched in 2011, right? So between 2011 and 2012 is when all the big players, i.e. Amazon, came out with Gen 2. Azure, with the reference architecture, started pushing a newer model of cloud, as well as Google starts kind of gets into the mix and starts trying to build out a cloud service. And then Oracle obviously was late because Oracle didn't change their model until 2018 for Gen 2, but 2017 they still had Gen 1. But the reason why they changed is because Gen 2's hallmarks were really around this DevOps mentality, container services, i.e., the rise of Docker, and then also a pay-as-you-go model, so more of a subscription service. So still kind of a demand, but more of a subscription service. And then people started figuring out, hey, I can use the cloud for development purposes, keep things on-prem. How do I make this hybrid model work? How do I define that in a little bit more extensions, right? And then from 2018 to 2020, this is where you saw the expansion of the cloud platforms, where a lot of the providers started going, hey, we can do all this thing. We can do hybrid clouds. We can do all these different things. And new terms started being thrown around like data mesh, right? How do I get my data on-prem into the cloud, vice versa, and make all this stuff work together? Well, that's where we ended up in 2020 going into the pandemic. And then throughout the pandemic, a lot of things changed. A lot of people structured their data pipelines and different things in that regards to scale out the environment a little bit more. But a couple of things went unnoticed, right? Processing of this data outside the cloud. So now you have all these cloud resources that you can use and scale up and horizontally, vertically, all these other things. But you forgot how to process data. The industry forgot how to process data. How do we get data to where it needs to be to process it? Because we're doing a lot of processing down on-prem, and we're trying to feed it into the cloud and try to make it all the structure work together. At the same time, a lot of heterogeneous resources went unnoticed, right? So yeah, throughout this whole time, we were talking about big data. We're talking about all this heterogeneous data. How do we move these things around and get all this data to where we want to do it so we could do all this processing? Well, the answer to that was really around GoldenGate. GoldenGate's been around for 25 plus years. GoldenGate can do 1,000 plus targets, and it can scale very easily. However, the downside for GoldenGate is really around the HA play, right? How do you make HA a solution here and still feed all these heterogeneous environments? That's a topic to discuss at a later time. But GoldenGate was really the front runner on taking all this on-prem data and going into a cloud-based environment, because it was, as I said earlier, it was just really, hey, we're taking these on-prem models and trying to put it in the cloud to make a demand model for things. And it took years for that to be structured out. Now, at the same time, we can argue the case that there's other competitors out there for GoldenGate, like Fivetran/HVR, or even Click, to say, hey, we can do all this heterogeneous stuff and move that into cloud as well. And those are valid arguments. Those are very valid things to do. And there's different providers. There's different applications that are running in the cloud, like Snowflake, Databricks, and a few other things that need to be fed to get to these models and do these architectural things as need be. But GoldenGate is the only platform that can really scale to meet the demand of all these things. There's some limitations of the other products in terms of the design aspect of being able to dynamically build for the cloud. And we'll get into that a little bit as we dive into this concept. So when we start talking about Zero-ETL, it's like, this is where I was going with this, is really, what is it? What's the terminology? What was this? What prompted this to happen? Well, it's really a type of integration that does not involve any ETL or ELT, because for years we've always been, hey, we got to do the extraction, the transforming, and then the loading to get to the analytic dashboards, to get to all these other pieces that we want to interact with. Or we flip it around and say, hey, we're just going to do the extract, the load, and then do the transformations. It's kind of really more of drop the ETL and drop the T and EL, and then it's Zero-ETL is nothing but EL, extract and load. It just gives us a data directly between systems without cleaning the data. Now, that's a problem, right? If you want to have certain data in a certain format, you have to do your transformations. You have to do these type of things, and you have to do them somewhere, and you have to do it either on the source or the target. GoldenGate for years had the ability to do transformations in flight, and that caused a lot of problems. So now we get to this concept. It's kind of like, where do we do our transformation? So it's just really Zero ETL is nothing but really moving data and getting it to the target system that you want to do. So it's a no thrills approach of data transfer and doing it very, very quickly. I had a poll, but I lost the poll screen somewhere. But anyways, I'll just ask this question and I'll answer it myself. First time used as a marketing term in 2002 by who? Right. So if you take the modern data platform timeline consideration and start thinking about this, it's really like who came up with this term? It was really Amazon. Amazon came up with the term zero ETL just for a marketing buzz term to get people to understand what they were trying to do within the Aurora stack, to get to machine learning, to get to all these other things. And they announced it at reInvent in 2022. That's the first time that this term has ever appeared in the industry. So when I was doing the research and I was diving into this, I was kind of going, well, Amazon 2002, 20 years later came up with this term, but we've been doing this for 20 plus years. Well, this is the approach that they highlighted, they illustrated, is that everything you do against an Aurora database is automatically replicated to a Redshift data warehouse where machine learning and AI and all these other things can be ran on it. And there's no need to do transformations because it's just one-way replication. You can just deal with it on the Redshift platform. Okay, well, to me, being that I've dealt with replication for nearly 20 years, I'm going, this is an old concept. So Amazon just created a new marketing term to say, hey, we're just going to move your data from the Aurora instance that you're using for your web interface or application or whatever else, and we're going to move it into a machine learning data warehouse for you. And you can do your transformations over there and run your machine learning models and do all the stuff that you need as data comes in, because we're just going to automatically shift that over. Okay, that's simple. Well, Oracle did it first. Sorry, I know there's some people that are anti-Oracle for various reasons, but when you look at the industry as a whole, Oracle has been doing this for decades. 2016 and earlier, Oracle GoldenGate Classic was used in thousands of use cases. Oracle bought GoldenGate in 2009. Prior to that, it was used in all the ATM systems around the globe, and then Oracle bought it, but it's been using Classic for. And there's a lot of people as we've been pushing to get into financial institutions, a lot of people are still using GoldenGate Classic today, and it's rock solid, and people don't want to move. All right. But when we start looking at the timeline of this, in 2017, microservices was released. 2018, this hub and spoke architecture was started or discussed, which allows for the additional terms of data mesh to be adopted. Right? It was really say, hey, data mesh is the new thing. So how do we architect a data mesh? Data mesh is really nothing but a bunch of hub and spoke architectures which allows you to funnel data to wherever you want to go. So take that to the ETL or zero ETL standpoint. You're just plugging and playing architectures, heterogeneous platforms at this point, and just moving data as fast as you can. And then that eventually led into the release of GoldenGate Service in OCI, where you can do multi-cloud plays and start going and moving data around very quickly. So if you got somebody running Snowflake or Databricks or whatever else in any of the other three clouds, and you got a data warehouse or a database as a service running in OCI, you can use GGS and very quickly move and point those things to different platforms. But you can also use the on-prem version of GoldenGate microservices and do the exact same thing. And I got a slide here shortly that will show you how you can codify the GoldenGate environment, which puts it ahead of a lot of the other competitors. But Oracle did it first. So when you start looking at the term data mesh, or you hear Oracle say data mesh or whatever else, I used to laugh at it, kind of going, we're not really a data mesh. We're just plugging things together. But data mesh is really a zero ETL concept. Excuse me. Which is just basically the same thing. Right. And so when you look at this in two different Oracle aspects, it's MySQL. Right. If you take the zero ETL format, you say, okay, I'm just going to use my MySQL database, similar to Aurora. my application is going to put data there, and then the MySQL replica is going to send the data onto the HeatWave service inside of OCI, and then you can pull back into the data back and forth if you wanted to. So it's got a little bit more functionality compared to Amazon's approach, because you're using the replicas to move data back and forth. Now, if you take it from a pure Oracle standpoint and just use GoldenGate, you got the heterogeneous architectures that you can pretty much feed everywhere, right? You can use GoldenGate service, GoldenGate on-prem, feed big data, do streaming analytics, send it to HeatWave or send it to Autonomous Data Warehouse and do machine learning on it. You can send it to Snowflake as well if you wanted to. Excuse me. But the whole point is you're not doing transformations, because actually in 2017, when microservices was released, the product team said that you should do your transformations on source or target. So that feeds right into this Zero-ETL framework and how it should be done across the board. And again, it's been around for 25 plus years. So the whole Zero-ETL thing, the benefit it brings to you is really a faster transfer of data, a more simplified approach of setting up your replication environment, that which drives down cost, because you're not doing transformations on the fly, but you're being more efficient, more quality, more speed of moving all that data, that which at the end of the day will get you to your target platform, that which you can do more data transformations on the target side, higher quality, more faster returns on investment from that data, and then you can get to your real-time insights very quickly. So you're just offloading the ETL functionality to the target platform across the board. Disadvantages of this whole thing is really limited data transfer capabilities. And what that really means is that in the past, and as we talked about pipelines here in a minute, is that you used to do batch processing, that you had to set up multiple steps to do things and to lay things out across the board. You compromise your data governance, where you basically say, hey, I'm going to wait until I get to the target side and do all my transformations. And so I have to do data cataloging and all that other stuff as well. So that inherently will put things more time onto your tasks at the other side. Restricted integration potential, straight data transfer. Yep. And so restricted integration potential, right, data transfer, so between systems. So the limiting factor here is going to be really, is the system inside or outside of your data system or your data ecosystem? How does that really look? So Stuart's got a question here. Stuart, I don't mean to call you out, but data quality has two meanings here: assurance that it matches the source is true, but data quality also involves the concept of correcting and enhancing data because it's not complete or is inaccurate at the source. That's absolutely correct. But in terms of this concept of Zero-ETL, you want to get the data to the other side as fast as you can. Then you're going to do that correction, enhancement, and transformation pieces on the target side. All right. So, i.e., your data warehouses should be doing more than just housing the data. It should be transforming the data and doing those things at the same time. And we're not restricting the replication of data at this point. We're just sending it as fast as we can, and then letting those particular platforms do the transformations and integration as need be. So a couple basic scenarios here. Which is the right approach, right? Is that organizations resort to ETL solutions to transfer data from transactional to data stores. Basic data warehousing, right? Is just like, but you're trying to do all your transformations somewhere along the pipelines. This is just really say, hey, use a replication agent. GoldenGate, ShareFlex, HVR, Click, all those things are CDC enabled, and you can directly mirror your data into your data warehouse, and then once it's there, do your transformations. Streaming analytics, right, is the same thing, but data streaming and message queues platforms channels the real-time data. So this is really your Kafkas and your big data platforms, and trying to get to that streaming analytics where you're doing the analytics on the fly across the board. All right. Excuse me. Oh, no, just next slide. So with this concept of ETL and just trying to push data as fast as you can, you've got to take into consideration that now we're just really talking about data pipelines and how data pipelines are really going to look and really going to work. Every CDC tool out there is going to tell you, yeah, I can do all these pipelines. I can do everything I want. But in reality, we've got two basic things we're doing. We're doing batch processing and then stream processing. Batch processing has been around since the very beginning. It's a critical step. It's where a lot of people go, hey, I got all this data and I need to mature it. I need to articulate it. I need to do something to it. But I'm going to do it on off hours. So that way I'm not impacting daily operations, because it could be large amounts of data doing a lot of things. But it's not really essential for analytics, because analytics comes at the end after you have everything transformed and set up the way that you need it. And then, but it's mostly associated with the ETL, right? We're just kind of pushing data along, doing what we got to do with it, curating it, and then moving it to where it needs to be. So it's batch processing. So Zero-ETL kind of speeds that up a little bit, because we're just moving the data across the board. But at the same time, what you have is the problem of with batch processing is the problem of commit, right? Because any CDC tool you use is going to have a commit thing that they have to key off of, because that's what tells the system that it's changed data. So if you're doing 100 million records and you're committing at the end of 100 million, you're going to see huge lags because of the commit, where the commits are. If you break the commits down to smaller portions, then it becomes easier to do batch processing across the board. Stream processing really boils into the continuously update of the data. So I'm doing a commit basically after every transaction. I'm pushing that data through, and then it's considered events when it gets to those platforms or topics and streams. So when you start looking at Kafka, or you start looking at other Hadoops and those type of platforms, you're just trying to get data into it. You're trying to get data to be continuously updated, and then you're trying to have as low latency as you can. So that's why it's happening after every commit cycle, or after every transaction there is a commit. But sometimes this could be less reliable as well. It's how fast are you moving the data to get there. So when you look at it from a Zero-ETL standpoint, you're really trying to get to a streaming model and push that data as fast and as hard as you can to that next platform, so you can use it for your data analytics and insights on that platform. But pipelines typically go through three phases. Won't spend a lot of time here, but data ingestion, right? Whether it's batch or streaming, you have to pull that data somewhere. You have to get the data from somewhere. So you're collecting all this data from various different platforms and trying to do something with it, because you're moving it into a transformation process at that point, and then you're getting stored into your data repositories or data warehouses. The Zero-ETL concept cuts the data transformation piece out and actually rearranges it, because it really should go data ingestion, data transport, and then data storage, and then transformation at the end. That's really the kind of the new model that we're moving into. Now, a lot of people will say data pipelines are different versus ETL pipelines. Well, you can make that comment and go that way. Well, but ETL pipelines really should be a subcategory of the data pipeline topic. It's not to give it any less value. It's just because ETL follows a specific sequence of events that has to happen, where data pipelines, we're just trying to move data as fast as we can and feeding it to that end target platform to meet the analytics or the machine learning or things like that we want to do. We got another question here. Yes, Stuart, you make some good points. Is that, stream processing is probably less reliable. We could argue the fact of being less reliable on stream processing. I think where they're going with that, or where we're going with that, is really the fact that data constantly changes so fast with stream processing, right? So if a record's not there, then it could be missing, and that causes an error, and that has to be looked at and adjusted for. Versus batch processing, you kind of have all that data there, and you're just doing it in bulk to get the data feed. So Less reliable may be the wrong term, but it could also be the concept of what you're looking at, how fast the data is actually being ingested. But I do agree that batch processing historically has been very brittle because there's a lot of things that has to happen in that mix across the board, that which you may have to restore a database or you may have to back up a database before you do a process, something like that. So, but at the end of the day, all these pipelines, it's all about speed. The zero ETL is all about speed because you're not worrying about that transformation process. And that's why the ETL pipeline should be a little bit more of a subcategory conversation across the board. So examples of data pipelines being used, and this is really where you get into the streaming aspect of these things. It's exploratory data analysis. Data scientists analyze and ingest data sets all the time, right? So when we're going from on-prem into larger data models, you want to be able to get that data there so these data scientists can actually summarize these character sets and characteristics very quickly and get their work done in a timely manner. So that's one use case. The other one is data visualization, but data scientists are going to use their models to give you the visualization that which you need to represent that. And then it's also to feed the machine learning models across the board. So, a lot of talk about AI here lately is great, but at the same time, you got to have these data pipelines feeding these models so that machine learning can be updated on a regular basis to get there. So between data scientists, analytic dashboards, and machine learning or artificial intelligence, you have to be able to move the data in high volume and very quickly. And so that's why there is the new term of Zero-ETL is just to get the data to where your platforms are to be able to do what you want to do with it. Right. So GoldenGate's really built around this concept. It's been built around this concept for probably at least the last 15 years because it enables you to do all these different kind of things. From distributed databases to applications to IoT to AI, ML, analytics, cloud data warehouses, data lake houses. All of these things have to be fed. And if you take the Zero-ETL model or the concept of it and just say, I'm going to flow data from point A to point B as fast as I can, GoldenGate's already there. A lot of the other competitors will say the same thing, but they're still operating in this GUI mindset of point and click, when everything going to cloud is really becoming more of a codified approach. You see that with Terraform being the code infrastructure as code. You're doing this as different aspects of big data modeling, of Python, doing machine learning. So everything's really we've gone through the history of, or through the era of GUI enablement. Now we're kind of going back to more of the analytics and data mining aspects of things, but using a code base to actually get it, where that poses a challenge because now you've got GUI tools trying to say, hey, I'm moving all this data at high volume. You can't do that dynamically with GUIs. You have to be able to codify that. And that's where GoldenGate with microservices has enabled a lot of that. So you can run GoldenGate across all the cloud architectures or across all the cloud platforms. It just depends on what you want to do. But all these use cases are still viable today, right? Some of these have changed a little bit from on-prem to on-prem type stuff, but on-prem to cloud, right there already. Multi-regional, right? Different clouds, multi-clouds. Enterprise transformations, you can do all the ELT if you wanted to, even though we're talking about Zero-ETL, but you can do, if you take the T off of that, you do your extract and load, you've got that from any source to any target. And then we now can do CDC extract from big data platforms. So now when things come into Kafka, we can actually capture from Kafka and move it on to somewhere else. So a lot of different use cases that it can be done through GoldenGate, which is probably about 5 years ahead of some of the other competitors with certain things. So just traditional pipeline, a lot of people look at this, but when we shift this thing to hub and spoke architecture, we're extracting our data through CDC processes into a hub, and then you're kind of taking the export data pump of this thing and dumping it into object store and then importing it into your next target. In this case, an autonomous data warehouse. It could be a Snowflake data warehouse, it could be Databricks, it could be whatever you want to go to. And then eventually you're going to start applying your CDC capture in there. And then you've got a single stream of pulling that data with some reason, with some resiliency in there because of the trail files that which are inherently part of GoldenGate to keep from network outages and stuff like that. Now, this is more of the traditional model where it takes, a lot of people complain about, hey, it takes us too long to initial load an environment or to move data around using export import and stuff like that, which are valid comments for everything. However, GoldenGate and microservices, they've enabled a lot of a file-based type of pipeline to where you can extract very quickly and load very quickly and get things done very quickly. So similar model, but you have your CDC extract, then you're going to do your initial load, but you're going to do your initial load through a file-based initial load. So you're going to use the extracts to pull the data out of the table itself into what they call EXT files. And then those EXT files are going to be read to load into the platform and then catch up with your CDC stuff. So it's a lot faster. It's a lot more structured. The only downside to it is you really have to have your DDL already in place onto the whatever platform you're going to, because the initial load through the EXT files won't necessarily pull DDL. It will pull DDL, but that's usually recommended to do it in a separate step as well. So just so that way you don't overload the platform. But by doing this type of file-based pipeline, you can achieve, and we've done this, to where you 3 terabytes of data transfer in 10 hours. That which is significantly faster than the traditional pipeline approach versus any of the competitors out there that I've worked with. So how did this pipeline come about, and how do you actually architect it? You can do it all in code. You can actually just simply go, this is all written in Python here. So each process that we just talked about with the CDC extraction and initial load extraction replicates, all written out into Python to be loaded into this thing. You can use whatever language you would choose or you want to structure with, and you can just load it out and go. And you can combine it. In this case here, we've got four different little scripts that which will build out each process. But you can actually take that a step further, and you can go into building dynamic pipelines through a single script. So when you start talking about pipelines, this was a concept that really started back in 2017 with GoldenGate microservices, because it was like, hey, we got these RESTful API calls now. Now we can build a whole pipeline in one command, in one structure, and it can be codified in any language you want to do. That allows you to use HTTP API calls. And so this example here, those 4 scripts on the previous slide, I did it in one file, and it's all written in this code way. As they start, excuse me, as Oracle releases 23C, probably around somewhere between April and July, it will, you have a new concept. They've actually built this into the GoldenGate product where you have pipelines built in to where it will actually do the whole process for you. You just say, I want this pipeline, and it will do every step for you across the board, the initial load and everything. And if you want to just check it out, in a week or so, I'll probably be doing a presentation around GoldenGate 23C free, that which actually will preview the pipeline concept of how this works. But because GoldenGate's gone to microservices, you can now codify everything, build dynamic pipelines, and leverage this Zero-ETL concept in high volume and really drive the analytics of your data, whether it's for machine learning, traditional analytics, or even data scientists ingestion across the board very quickly. So what I like to say here recently has really been that GoldenGate's really the glue that connects it all together, right? And you can do this now in a dynamic fashion across the board. Get rid of put your transformations on the target side, and really drive the data ingestion feature quickly and then do your transformations to get to where you want to be in terms of data scientists, analytics, big data, wherever you want to go. And you can pull from all the heterogeneous platforms. I've been answering questions throughout. So is there any additional questions? If not, I'm not the AI, but you can ask an AI additional questions if you would like. So with that, I don't see anything else popping up here, so I'm just going to move on. So with that, if you want to get a hold of Rio Data, this is just our contact information. Feel free to reach out to us. We can help you with all of your data pipelines. Now, this presentation was heavily on GoldenGate because, like I said earlier, it was like I thought it was interesting for a new marketing term to come out, but yet the concepts have been around for decades, if not longer, with all the platforms we use today. But reach out to us. We can help you not only with GoldenGate, we can do the 5-tran HVR stuff. We can do the click stuff as well. And there's some things coming with not streams, but Shareplex in addition to that. So with that, I appreciate everybody who came, asked questions and everything else. So look forward to talking to you again soon. Thanks. Bye.